In this video, we will learn about image formation by a thin convex lens. Now, we know that a convex lens may either form a real or a virtual image of an object depending on the position of the object. Now, to know the position, nature, and size of the image formed by the convex lens, we consider the following situation. First is when the object is at infinity. So, when object AB is at infinity, the light rays starting from infinity form a parallel beam of light. Now, if incident beam of light is parallel to the principal axis, like this, then after refraction from a convex lens, all these rays passes through the principal focus, that is f2. Now, on the other side of the lens, hence a real, inverted and point size image is formed on the principal focus f2. However, if the incident parallel beam of light falls on the lens obliquely, like this, then ray 1 is passing through the optical center goes undeviated, and ray 2 passing through the focus point f1 after refraction emerges parallel to the principal axis. Now the two refracted rays intersect at a point A dash. Hence a real image A dash B dash is formed in the focal plane of the lens on the other side. Now this image is real, inverted and highly diminished one. Second is when the object is situated beyond 2f1. In such cases, let a linear object AB placed beyond 2f1 of a convex lens. Now, let the light rays AL traveling parallel to the principal axis of the lens after refraction passes through the focus f2. Another ray AO which passes through the optical center goes undeviated along its original path. Now, these two refracted rays intersect at a point A dash. Thus, an image A dash B dash is formed somewhere between f2 and 2f2. This image is real, it is inverted and diminished in size. Third is when the object is situated on 2f1. Now, if the object is situated on 2f1, then let AB be the object which is situated on 2f1 normally. Now, light ray AL traveling parallel to the principal axis after refraction from the lens passes through the focus point f2. Now, another ray AO passing through the optical center goes undeviated. Now, these two refracted rays intersect at a point A dash. Thus, as given in the figure, an image A dash B dash is formed at 2f2. Now, this image is real, inverted, and of same size as that of the object. When the object is situated between f1 and 2f1, now let a linear object AB be placed normally somewhere between f1 and 2f1. Now, let AL be the light parallel to the principal axis, and after refraction from the lens it emerges from the focus point f2. Another ray AO passes through the optical center goes undeviated. Now these two refracted rays intersect at a point A dash. Thus, as shown in the figure, an image A dash B dash is formed even beyond 2f2. This image is real, inverted and enlarged one, as you can see in this particular figure. This is the object and this is the image. Fifth is when object is situated at the focus point f2. Now in such cases, let a linear object AB be held normally on f1. Now light ray which is AL traveling parallel to the principal axis after refraction passes through the focus point f2. Another ray AO passes through the optical center goes undeviated. Now these two refracted rays are parallel to each other and meet at only infinity. Now, thus an image is formed at infinity. Now, this image would be very far away from the lens. Also, it would be real, inverted, and highly enlarged. Finally, if the object is situated between the focus point f1 and optical center O of a convex lens. Now, let us suppose AB is that particular object. Now, light rays from AB, the first one that is AL, traveling parallel to the principal axis of the lens emerges after refraction through focus point f2. Now, another ray AO which is passing through the optical center goes undeviated. Now, these two refracted rays do not meet at any point but appear to diverge from point A dash, right? Thus, an image A dash B dash is formed on the same side of the lens and the image is virtual, erect, and enlarged image. Now let us summarize all these through a table. Now, when the position of the object is at infinity, then we will get the image at focus on the other side. Now, this image is highly diminished and the nature is real and inverted. Second is, if the object is beyond 2f1, then the position of image will be between f2 and 2f2. Now, the size is diminished and the nature is real and inverted. Now, if the position of the object is at 2f1, then we will get the image at 2f2. Now, the image size would be same as that of object and it is real and inverted image. Now, if the object is between f1 and 2f1, then we will get the position of the image beyond 2f2. Now, it is an enlarged image, real and inverted in nature. Now, if we place the object at the focus on one side, then we will get the image at infinity. Now, the size is infinitely large, that is highly enlarged. It is real and inverted in nature. Now, if we place the object between focus point f1 and optical center O, then the position of image will be on the same side as that of the object. The size is enlarged and the nature of the image is virtual and erect. I hope this topic is clear to you. Thank you.